Okay, so this is a review of test 3 material, and I need you to please take a moment, look at the details as I go over the information. So I gave you some review questions, and I'm going to go over the topics. So starting with, I guess, topic number 1. If I were to look at, say, a function, say I have f of x, and that function is, let me just do this real quick before I continue. Make sure that I am sharing the screen, because if not, you're going to get to see my picture the whole day and listen, which is not bad. But now, okay, there we go. So in this question, I'm going to ask you, if I'm giving you a function and I say I have a negative of a quadratic, such as this, and I'm asking you simply to tell me what is the vertex. Okay, that's negative b over 2a. That's the x value. If you want the y value, you got to plug in f of negative b over 2a and get the value, and that's your y. So in this case, we're going to take negative 6 over 2 times negative 3, which gives you negative 6 over negative 6, which is equal to positive 1. So I have this as 1. Now I need the y. So to solve for that, I will do negative 3 times 1 squared plus 6 times 1 plus 1. Okay, and so this is 1 squared. So this is negative 3 times 1 plus 6 times 1 plus 1, which is basically equal to 4. So that means that this answer should be 1, 4 for the vertex. Okay, remember this is the axis of symmetry. This is where x equals 1. This is the axis of symmetry. We find this by using negative b over 2. Okay, number 2 example. And again, if I write you an vertex formula, this is a parentheses x minus h squared plus k normally. In the vertex, we're using the opposite sign of the h, and we want the k. So in our example, the vertex of this would be h comma k. So I'm going to give you an example. So for example, let's say I have 3 minus parentheses x plus 4 squared. What I want to do is consider that this is the a value and this is the vertex. This b value has to be moved. So this is really negative of x plus 4 squared plus 3. And so as a result, I know that the vertex is negative 4 comma positive 3. This is always the opposite sign. This is not. Okay? Let's look at example 3. If we look at example 3, we have, again, another example of how we're going to use negative b over 3a. Because in example, they're asking you to find a range of a function. And they're giving you a quadratic. They're giving you negative 3x squared plus, say, 3x in this case. So we could use negative b over 2a to find the value. So negative b would be negative 3 over 2 times a, which is also negative 3. And this is going to give me negative 3 over negative 6, which is positive 1 over 2. That is x equals. I want the y, I got to plug it back in. So I have negative 3 parentheses 1/2 squared plus 3 parentheses 1/2. So this is going to give you negative 3 over 4 plus 3 over 2. But remember that you need to have a common denominator, so you're going to multiply by 2 here and here. So this becomes positive 6 minus 3, which is positive 3 over 4. And that is your answer. So your answer for this should be, because this parabola is facing down, and if I graph it on Desmos, I can prove it to you. So let's go to Desmos. This is negative 3x squared, and this is positive 3x. And if you look at the vertex, boom, you can see that it's positive 1/2 and positive 3 over 4. Okay, so be careful with the notation. And it is inclusive, and this is why you'll see that in our notation, we're going to use, in this case, because we're coming from the bottom up. Again, remember, if you remember our drawing, this is at positive 1/2. So let's say 1/2 is here and 3 over 4 is here. This parabola is facing down because this is negative. And so we come from negative infinity. We come from the bottom up to that point. And this is going to be comma 3 over 4, but this is inclusive. This is always a parentheses. Okay. Question number 4. Find the x-intercept of anything for the graph of the quadratic function. Okay, so here's your quadratic function. You have f of x is equal to negative of x squared plus 17x minus 72. Now here's what I want you to focus on for 1 second. See that negative? You're going to re-express this equation as negative x squared plus 17x minus 72, and you're going to say that equals 0. You're then going to multiply the entire equation by negative 1. This makes the new equation positive x squared minus 17x plus 72, and it still equals 0 because negative 1 times 0 is still 0. I can factor this easily. X times what is x squared? X times x. If this is minus 8, this has to be minus 9 to give you a positive 72. And so your x-intercepts are 8, positive 8, comma 0, and positive 9, comma 0. In question 5, they're asking you what is the y-intercept for the graph of the quadratic function. And they're giving you the graph as y plus 9, and that is equal to x plus 3 squared. Remember that all you need to do here, technically, for the y-intercept, remember that means that x equals 0. So that means that y is equal to 0 plus 3 squared plus minus 9, because I'm going to subtract the 9 and move it to this side of the equation. And this is my new equation, which when I work it out, is going to give me y equals 9 minus 9. So therefore y equals 0. So my solution set has to be 0, comma 0. Okay. Let me do a stop share for a minute. Okay, the next question I have for you is number 6. In question number 6, they're asking us to find the domain and the range for a quadratic function. quadratic functions have a quality where the x values or the domain is always negative infinity to infinity, unless you're restricted on purpose. So you have to purposely go in and restrict it, in which case that we're not. So the domain is always going to be this until the day you die. Now, they're telling us there's a minimum. The fact that it's a minimum is, that means to me that this has to look in this location, where this has to be a equals a positive number, whatever it is. So that means if they're telling us that a value is positive because it's a minimum, if it's a maximum, just for the record, it'll be upside down. It'll look like this. It's a max. It'll look like this. If it's a min that they're asking for, it looks like this. So I already know that this minimum is -1, -6. Because I always look for the minimum for where it starts. In this case, this would be -6, positive infinity. So -6 positive infinity for this should look just like that. Okay, if it were the opposite and they were asking for a maximum, then our number would be up here, but that's not the case. Okay, number 7. Now they're asking us here to determine if a quadratic has some minimum or some maximum. You need to remember in the function, I have to look at the a value. The a value is crucial. So in our case, the a value is +2. If this is a +2, this diagram will open like this. So this has to be a minimum, whatever we're looking at. So in this case, we're here. If that is the case, then we need to use our axis of symmetry (b/2a), which in this case is -4 over 2 times a, which is 2 times 2. So if you notice, it gives you 4 over 4, which is 1. So eliminate any answer choice that doesn't have +1. If you want the y value, that means 2 times 1 squared minus 4 times 1. So this gives me 2 minus 4, which is equal to -2. So my intercept down here is +1, -2, and it's a minimum because it opens up. It opens up, a is positive. Positive a, always remember, positive a. This is where we're looking at ax squared being positive plus bx plus c. If it were negative, then I'm looking at a maximum. And if you remember, in the maximum, we have this behavior where we have -ax squared plus bx plus c. So there you have an example of that type. Okay, let's look at number 8. On number 8, you're given 3 factors. So you have an x plus 4, we have an x plus 3, we have an x minus 7, and this is greater than 0. So it has to be positive. A positive result is what we're looking for. Now, you can tell because these are the intercept or factors. This is a -4, this is a -3, this is a +7. So drawing a number line, where here's negative infinity, here's positive infinity. So number line wise, this would be -4, this would be -3, and this will be +7. So we're going to use our test points. Simple test point between -3 and 7 is 0. I love that test point. Another test point that's easy is 8. Another test point that's also easy is -3.5. And another test point that is also easy to use is 5. And so now what we're going to do is we're going to implement those values in here. So this becomes -5 plus 4. This is -3 plus 3. And this will be 8 minus 7. And they have to be greater than 0. So if you notice here, I'm going to write the rest of the expression. So this is plus 4. This is plus 3. This is minus 7. And so writing this out, this gives me -1 times 0. Forget about it. So this is actually equal to 0. And this is 1. It's not greater than 0. So if I tried 6, for example, maybe, or a different number. Actually, no, I'm sorry. This is 3.5, not just 3. My mistake. 1 second. Let's change this real quick. So this is now going to be 3.5. And this is now no longer 0. This is actually -0.5. So do the math. -0.5 is a positive. So this actually becomes a positive. And yes, this is greater than 0. So this checks out. We know we do the same. I think I have made a massive mistake here. So disregard this question for a minute, or what I just did for a minute. So we're going to go back to this equation and we're going to actually implement this differently. So this is going to be the original question here. I had interruptions, and that's all it takes is one little interruption and I am off the loop. So we'll try the -5 first. So if I do -5, it'll be for all of them. And that's the mistake I made. So if I put in -5 for all of them, this is going to give me a -1. This is going to give me a -2. And this is going to give me a -12. So my solution here is negative. So this is not an interval that I would consider. So from -infinity to 4, -4 is not a possible solution. Okay, we repeat this process. Let me switch pages. This is getting a little cumbersome here. Let me switch. Bear with me. Page. Okay, let's continue with the same question. And so I'll do the same thing again. So the next question I had was, I'm going to rewrite this. This is x plus 4. I have a number, and this is some x plus 3. And over here I have another value, which is some x minus 7. And this is greater than 0. And once again, think of our number line. Here's -infinity, positive infinity. I'm looking at -4, -3, and 7. And as I said, I had chosen -5, which we said is a bust, so I'm not going to worry about that. There's a 0 here. I'm going to try the 0. There's an 8. I'll try the 8, and this is -3.5 here. So if I try the negative 3.5, I'll put that here. I'll put that here, and negative 3.5 here. So this is negative interval. This is a negative interval. This is a positive interval. So this actually is a positive solution. That's a winner. So one of my answers will be the interval between -4 and -3. So that's a yes. Let's do 0. If I put a 0 here, a 0 here, a 0 here, 0 plus 4 is positive, that's positive, and this is negative, so I'm going to get a negative answer. So this is not a solution. And lastly, over here on the 7 to infinity, I have 8. So let's make these 8s. You look at this, I have a positive 12, a positive 11, a positive 1 is positive also. So this interval is a winner. So it looks to me like these are my two solutions. So this would be answer choice C in your review packet. For number 9. Same difference in this one. They're giving you a cubic function. So we have 16x cubed plus 48x squared minus 25x minus 75. And this is greater than 0. So I'm going to factor by grouping. I'm going to take out 16x squared. This is going to leave me x plus 3. If I take out a negative 25, this is going to leave me with x plus 3 again. And obviously greater than 0. So that means that I have a perfect square here. So 16x squared minus 25. And here I have x plus 3. And this is all greater than 0. So this factors further. This is a 4x plus 5 times a 4x minus 5 times x plus 3. And this is still greater than 0. So it means that one of my solution points in this case is -5 over 4. And this is positive 5 over 4. And this is -3. And so again, we're testing for a positive outcome. This is negative infinity. Here's positive infinity. So I have, in this case, if you remember, this is 1 1/4. So you have negative 1 1/4, positive 1 1/4, and -3, which is down here somewhere. So my test points that I'm going to try, let's say I try 2. 2 is a good number. Here, I'm definitely trying 0. Here, let's do -2. And here, let's do -4. And so one more time, we're throwing this into our equation. So technically, you could use what we have here. Might be a lot easier. So this becomes, for example, 4 times -4 plus 5. This is 4 times -4 minus 5. And this becomes -4 plus 3. And you're trying to make this greater than 0. So this is a -1. This is -21. This is -11. So this answer is a negative answer. This is not an interval to choose because we need a positive. greater than 0. Repeat the process, and if you notice, I'm simply going to eliminate these old negative 4s, and let's change these to negative 2. So negative 2, 2, negative 2. See what we're getting. So this is going to give me positive 1. This is negative 8, negative 5, which is negative 13. Negative 8 plus 5, which is negative 3. So this is positive. Okay, and that's good. So from 3 to negative, I should say negative 3 to negative 5/4 is good. So this is good. This is one of my yeses. My other yes possibly could be the 0 I'm thinking because of math concepts. Just know how. If we use the 0, 0, 0, and 0, this is going to give me again. This gives me positive 5, that's positive. This gives me negative 5, that's negative. This gives me a positive. So no, this is negative, this is no good. So that's no good. The 0 is no good. Came close though. Okay, and now the last piece I'm going to try is this 2. So let's try the 2. Don't assume it's going to work. We always try. So this gives me 8 and 5, which is positive 13. This gives me 8 minus 5, which is 3. 2 plus 3, which is 5. Those are all positive, so yes, this is a winner. So my other solution is from negative 5 to infinity. So yes, that's a winner. So I think for you guys, this is answer choice B. So when you answer this, remember it's a union. So it's negative 3, negative 5/4. And this is union, positive 5/4, comma, infinity. I'm going to do number 10. Let's take a look. Number 10. Number 10, you have an x minus 1. You have a 3 minus x. And this is all over x minus 2 squared. This is less or equal to 0. And so for this one, I'm thinking that if I look at these intervals, so I'm looking here at negative infinity, here's positive infinity. So we know that this is x minus 2 squared. So looking at a cutoff, I'm looking at positive 1. I'm looking at another cutoff as positive 3. And I'm looking at another cutoff which is a positive 2. And so let's look at these intervals. If I'm looking at test points, a test point here, I'm going to definitely choose that 0. And I'm looking here for a negative because it's less than 0. Okay, so that's 0. Choose a 1.5. I'm going to choose a 2.5. And I'm going to choose, say, a 4. So if I do that, the 0 minus 1, times 3 minus 0 all over 0 minus 2 squared. This is going to result in negative 1 times 3. And this is negative 2 squared, so it becomes over 4. So this is equal to negative 3 over 4. And that is definitely a winner. So this is one interval that is to be selected. So anything from negative infinity up to 1, we can even do inclusive up to 1 because of the fact that it is negative. Okay, so the 0 works. Let's try a 4. So we want a negative outcome. So this will give me 4 minus 1 times 3 minus 4. And you notice why I jumped to the 4 because of that negative. And this is going to give me 4 minus 2 squared, which is 2 squared anyway, right? So 4 minus 1 is positive 3 times negative 1 over 2 squared. This is definitely going to be a negative number because it's going to give me negative 3 over 4. So this interval is another winner. And we could say it is also inclusive to infinity. So I'm going to go with union 3 comma positive infinity. Notice that I'm not even going to bother with the middle. And the reason is I know I'm going to get positives all around. So for example, look at here for just 2 seconds. We know it can't be 2, but let's go with 1.5. Even if I have a 1.5 in here, minus 2, that answer is negative and it's squared, so it still becomes positive. And over here, if this is positive 1.5 minus 1, and this is 3 minus 1.5, do you notice that you end up with a positive? I did the same thing with a 2.5, just guesstimating to get the same thing. And you can see that it's still positive. We don't want positive, we want negative. Okay. Let's look at number 11. In number 11, you have x plus 9 over x plus 2. This is less than 5. So step 1 is to subtract 5. So you get x plus 9 over x plus 2 minus 5 over 1. What you're going to do is you're going to multiply by x plus 2, top and bottom. Okay. Up on top, which is what I'm going to focus on right now, I want you to notice that this is x plus 9 minus 5x minus 10. If you just distribute it right away, you don't have to worry about it. And all of this is over x plus 2, which is now your common denominator. So if I simplify this further, I'm going to collect like terms. I'm going to collect the 9 and the negative 10, the x and the negative 5. So I get basically negative 1 minus x over x plus 2. I'm sorry, negative 4x. I'm having a moment. Negative 4x at the top. Right? Negative 5x and x is negative 4x and negative 1. All right. So as I'm looking at this, I'm looking at x cannot equal, obviously, negative 2. And x, in this case, also cannot equal negative 1/4. So set these both to 0. Remember I said this is the one where you set them both to 0 at the end. Obviously, x plus 2 equal to 0 means that x is equal to -2. And that's why this, right? And on the other side, you have -1 minus 4x equal to 0, which means I'm going to add the 1. So you have -4x equals +1. And you're going to divide by -4. So therefore, x equals -1/4. And that's what x cannot equal, because that is what x equals when it's 0. Draw your number line. Here's -infinity. Here's +infinity. So here is -1/4. And here is -2. So obviously I'm going to choose a test point on this side, which is 0. I love 0 for our test point. I'm going to choose -1, which is a number between this, and I'm going to choose -3. So these are my test points. I have 3 test points. We are going to throw these back into the equation. So according to the equation, it was x plus 9 over x plus 2. And obviously this has to be less than 5. So -5 is equal to or less than 0, right? So we're just subtracting the 5. So if it's 0, so just to test it quickly, if it's 0, and you put in 0 plus 9 over 0 plus 2 minus 5, obviously that's a negative number. So that's a winner. So I know right away one of the solutions is -1/4 to infinity. Definitely that. Common sense, I'm looking at the -1/4, and I almost don't feel like testing it. Let's test a -2. -2 plus 9, that's positive. And -2 plus 2, well, that's going to give me 0. -5 is what's left, and that is less than 0. That works because that is also negative. So technically, this works. -infinity to -2 works. You want to try the -1 for the sake of trying it. So -1 plus 9 over -1 plus 2 minus 5. Is that less than 0? But it's going to give me +8 over 1 minus 5. Is that going to give me what I need? Number 1 is 8 minus 5 is 3. That's actually a positive number. That is not meeting my criteria, so that's why I didn't bother. And that's just a matter of getting very used to your numbers. Let's look at number 12. More of the same. You have 2x over 6 plus x. I mean, x plus 6. And we're going to subtract the x, and this is now going to be less than 0. This is over 1. So we're going to multiply top and bottom by x plus 6. So your common denominator will become x plus 6. So this is 2x minus x squared minus 6x over x plus 6. And this is less than 0. You may want to restructure this, which if you restructure it, you get -x squared minus 8x, no, minus 4x. This is just going to cancel out 4x. And all of this over x plus 6. And this has to be less than 0. So when we look at number 12, let's look at any possible solutions. We know x cannot equal -6. X cannot equal -6. And if we solve for the top, take -x² minus 4x and set it to 0. That means if I multiply the whole thing by -1, I'm going to end up with +x², positive 4x equal to 0. So this is x times x plus 4. That's telling me that x cannot be 0 and x cannot be -4. So these are the no's. So if this is a case, we draw our number line. Here's -infinity, here's +infinity. So we have -6, we have -4, and we have 0. So let's do some test points. Let's do -7, -5, -3, +1. And so we need to see what works. So I'm thinking, let's do just based on number sense. This is 2x over x plus 6. And this has to be, again, negative. If I subtract that one more time, so let's subtract it. So it's just a reminder. So this is really 2x over x plus 6 minus x, and that is less than 0. So, okay, so let's try our test points. Let's try the 1. I know the 1 for sure should be giving me a negative. I know why. So think about it. 2 times 1 over 1 plus 7 minus 1. Is that less than 0? And so this is 2 over 8. So 2 over 8. So 2 over 8 minus 1. That is definitely less than 0. So that is, I was correct. This is definitely one of my areas. Will be possibly 0 to positive infinity. Union the other sides. Let's see what we get. Let's try I know that the -5 is also going to work, and I know why I'm saying that. If you do 2 times -5 over -5 plus 6, and that is minus -5. So it's always minus x. So this is going to give you -10 over 1 plus 5 over 1. But I have to multiply this by 2, top and bottom. No. No, I don't. Actually, this is not a common denominator issue. If you notice, this also results in -5. Right? It's -10 plus 5. So yeah, that's a winner. This is definitely an interval that will work. Now, to prove to you that the other two do not work, if you do 2 times -3 over -3 plus 6, and this is minus 3, and this is less than 0, this is going to give you -6 over +3 plus 3 over 1, which means I'll get a common denominator times 3 times 3. This will give me 9 over 3. So the final answer here is going to be a positive integer. So not what we want. That's why that is not in the interval. So it looks to me like the other interval, like I said, was the value between 6 and -6 and -4. All right. And same thing for the 7. You plug in the 7, you see the same behavior. Okay. Let me get another page. And let's do numbers 13 to 20. And so, all right, there you go. Number 13. On number 13, we have y equals 25 minus 6x. They're giving us another equation of 6x plus y equal to 31. Now, I have said this multiple times that you do not even bother with this unless you have an x column, a y column equal to the answer column. So in our case, we have to add the 6x over here and bring it to this side. So you end up with, in this case, you end up with 6x plus y equals 25. 6x plus y equals 31. And if I were to subtract one of the lines, let's say I subtracted this line, you notice you end up with 0 equals, some number. Not possible ever. Null set. Number 13, that was 14. Let's go 14. 14, you have another system. You have 3x plus y, and this is equal to 11. Here you have 9x plus 3y, and this is equal to positive 33. So that tells me that I may want to move or multiply this equation by negative 3. So this becomes negative 9x minus 3y, and that equals negative 33. So if you notice in this equation, 0 is equal to 0. That is a true statement. Because it's a true statement, this means that there are infinitely many solutions. So that means that some value of x and y is going to result in 3x plus y equal to 11. They may also express this as some xy, and the solution could potentially also be 9x plus 3y equal to 33. Okay. So I'm going to pause the video here, and more to come in the next